Okay, today we will have a presentation by group, okay, on the project. So at first you have to identify the problem and take a case study, and you have to use the advanced analytical model. So try to get a data set and provide detailed solution using deep learning techniques in artificial neural network. Okay, and then you have to provide step by step on how data be analyzed with deep learning, right? You can use this guide as a cross-industry standard process for data mining, where you can use for your project. Alright? And today we will have a project presentation with the project leader and the group members. Okay? Okay, thank you.
Hey lads, I want to welcome you to our project, 50 Shades of Green, a plant disease detection system using deep learning and specifically CNN.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is ABDULRAHMAN Majid. Today I will present our project. It's called 15 Shades of Green. It's about using deep learning to find plant disease from picture of leaves. In introduction, plant disease are a big problem from farmers. They reduce crop production. We use AI to help find this disease early by looking at left image. Many farmers don't have access to expert. This make it hard to know what wrong with their crops. Our idea is to use computer model that can look at left image and tell if the plant is sick. Introduction to case study. We use MobileNet V2 and trained on dataset called Plant Village, which has many picture of healthy and sick leaves. We use Python and Google Cloud to build and run our system.
Assalamu alaikum warahmatullahi wabarakatuh. My name is ABDULAZIZ Ali SALEM. I will continue after my friend ABDULRAHMAN Majid. Our project uses MobileNet V2, a type of CNN, to detect plant disease from the Plant Village dataset. It's built with the Python and TensorFlow, making it easy to use and run without powerful hardware. The goal is to help farmers support disease early and reduce crop loss. Deep learning is a type of machine learning that mimics how the brain works. In our project, we used a CNN model called MobileNet V2, which is good for image task. It was pre-trained on ImageNet, and we tuned it using the Plant Village dataset to detect plant disease. Python was chosen for its simplicity and support for deep learning tools like TensorFlow
Deep
and
learning is a
Keras.
subfield of machine
These
learning
tools
focused
make
on a
it
model that
easy to
simulates
build
the
and
human brain
train
neural
CNN
network.
models
In
that
this project, we
can
utilize a convolutional
accurately
neural
classify
network known
plant
as
disease
CNN,
from left
which
image.
is highly effective for image-based tasks. We choose MobileNet version 2, a lightweight CNN
Key
model pre-trained on
libraries
ImageNet and applied transfer learning by fine-tuning
TransferFlow
it with the
cares
Planet Village
for
dataset.
building and training the
Python has
model.
chosen due to its
OpenCV
simplicity and
Python
strong
for
support for
loading
deep
and
learning libraries
testing image.
like TensorFlow and Keras. These
Matplotlib
tools
for
streamline the process of building,
visualizing
training, and
accuracy
evaluating
and
deep neural
loss.
network. The
Schedule
combination
for
of Python and
downloading and
CNN
using the
allows the model
dataset
to learn
automatically.
distinguished features from leaf image, enabling accurate classification of plant disease. Key libraries that we used: TensorFlow Keras for model architecture and training, OpenCV Python for image loading and testing, Matplotlib library for visualizing, training, accuracy, and loss, Kaggle for automatic dataset download and integration. Detail on the DL functions. The deep learning model used in this project is built using TensorFlow and Keras. The core model structure is based on MobileNet version 2, pre-trained CNN, optimized for efficiency and accuracy.
Hey, welcome back. And now let's go over the key component layers. Start with the input layer, which accepts images and resizes it to 2 by 24 and 2 by 24 pixels, each with the three main color channels. Then we have the base model, which has the mobile.net v2 without the top classification layer, used for features and extraction. Then we have the global average pooling, which reduces each feature map to a single number, minimizing overfitting, which is a key component in CNN models. Dense layer, which is fully connected layer with 256 units, and real activation to learn non-linear patterns. This helps the model itself learn without increasing the number of data that is needed. Now going through to the dropout, which randomly drops 40% of the connections to prevent overfitting. Again, in this type of model, an incorrect assessment due to it seeing patterns that are not there is typically critical. Then going to the output layer, which is a dense layer with softmax activation with neurons equal to the number of plate disease classes. Now the model is compiled using the loss function, categorized cross-copy, and optimization, which is using ADAM, adaptive learning rate. Now the metric to calculate the utility is accuracy, and the model is trained using a .fit method and saved with a .save for later use in predictions. Now let's go through the step-by-step learning analysis and finding. The learning pipeline was systematically designed using the following steps. Data processing. So we got this data set from Kaggle. It's called Planet Vision, a village, which categorizes plant diseases with the pictures to show said diseases. And then we organized it into labeled directories. We used image processing and augmentation using image generator with techniques such as Z-scaling, random rotation, and horizontal flip. Then the data was split into 1820 for training and testing. We used set techniques again to increase the accuracy of the prediction without needing to add more data. Now going over to model architecture, a transfer learning approach was employed using the mobile net v2 as the base model to its balance of efficiency and accuracy. The base was frozen to preserve pre-trained weights. A custom classification ahead was bended. We used a global average pooling 2D layer to reduce spatial dimensions. We used dense for future extractions, and we dropout to reduce overfitting. We also used dense for multi-class outputs. And now to conclude, we believe that this project has successfully applied a deep learning approach using MobileNet v2 to classify plant leaf diseases. The use of pre-trained model combined with robust data augmentations techniques and well-structured architecture resulted in high accuracy and strong generalization. The outcome affirms that the transfer of learning is a powerful tool in architectural design, diagnostics, and particularly when computing resources are labeled and data is limited.